Welcome. Your agent is exposed to the world once it is deployed into production. Every request that comes in is essentially asking your agent to do work. But should your agent do that work? In this video, we'll look at how Agent Core Identity helps your agent answer that question. We'll go behind the Agent Core API calls to understand how the whole process of authorization is orchestrated. So, how does your agent know who to trust? We will answer this question in two parts. Part 1 is during configuration. Before you even deploy your agent, you need to confirm who is allowed to call your agent. And part 2 is post deployment. During invocation, you need to verify the caller who is invoking your agent. Is a caller who they claim to be? Who can access my agent is addressed during configuration. You start with an identity provider you trust and supports OAuth 2.0. Identity provider's discovery URL is passed to Agent Core Runtime while configuring the agent. Why? Because this URL tells Agent Core Runtime how to use the provider to authorize calls to your agent. You also provide a allowed clients list, which is essentially your guest list. These are the specific applications you are granting access to. If a caller's ID isn't on the list, they are not getting through. Shown here is a CLI example. You can do the same with Bodo 3 or with Agent Core SDK. We have an agent available which can take action on requests from callers. But is the caller who they claim to be? The caller needs to prove its identity. It does this by authenticating with the identity provider your agent trusts, and it needs an indisputable way to convey that identity to Agent Core Runtime. That's the bearer token. Once the client has the token, it passes it along with the invoke request at runtime. The OAuth dance, which is the token exchange, the secure credential storage, is all handled by Agent Core. You focus on what your agent does with the data. From here on, we are going behind the scenes. We will see what Agent Core does for us. You're now ready to deploy your agent into Agent Core Runtime. When you run Agent Core deploy on Agent Core CLI, the CLI takes the agent code and the authorization configuration you just defined and sends it to Agent Core Runtime. The runtime creates or updates your agent and stores provider authorization configuration for the agent. Once stored, it returns a runtime ARN back to the CLI. And that's it. Deployment complete. Your agent is now live and secured with the authorization configuration you defined. Before invoking your agent, the client application can get its bearer token in few short steps. The client application uses the client ID and client secret for the identity provider to make a post request to the OAuth provider's token endpoint. The OAuth provider validates those credentials and, if valid, generates a JWT. This token contains important claims: the issuer, subject, audience, expiration, and scope. The provider returns this JWT as the access token along with the token type and expiration time. This is the token the client will use to prove its identity when invoking the agent. Now your client has a token and is ready to invoke the agent. It prepares the request payload and makes a post request to the agent's invocation endpoint. The key here is the authorization header. It includes JWT as a bearer token. The outcome is a response back to the caller. But how did Agent Core Runtime confirm the caller's identity and authorization? That process is orchestrated behind the scenes, and it starts with extracting JWT from the authorization header. Agent Core now has a JWT which has certain claims about the caller: who they are, what they're allowed to do, and when the token expires. But how do we know these claims can be trusted? Because the token is signed by the OAuth provider. To verify that signature, Agent Core Runtime needs the provider's public keys, available in provider's JWKS or JSON Web Key Set. First, Runtime checks its local cache for provider's JWKS. If the cache has the keys and is still valid, it uses them directly. If the keys aren't cached or have expired, Runtime reaches out to your OAuth provider. It calls provider's OpenID Connect Discovery endpoint to get the location of the public keys, then fetches them and caches them for future use. With the public key in hand, Runtime is ready to validate the token. AgentCore Runtime checks several things: the signature to ensure the token hasn't been tampered with, the issuer to confirm it came from the trusted provider, the audience to verify the token was intended for this agent, expiration to make sure it's still valid, and client ID to confirm the caller is on the allowed list. If all checks pass, JWT is valid and runtime proceeds to execute the agent. If any checks fail for invalid signature, wrong issuer, expired token, or unauthorized client, the request is rejected with a 401 unauthorized response. Once JWT is validated, the runtime proceeds to execute the agent. Agent core runtime invokes the agent container with the input payload and the client ID. The agent executes its logic and returns the response. That response flows back through the runtime to the original client with an HTTP 200 OK as the status. So far, we have talked about validating attributes like issuer and expiration. But what if you need more granular control? What if you want to allow some clients to read data but not write, or restrict access to specific departments? That's where scopes and custom claims come in. These are additional checks you can configure in your authorizer to control exactly who can access your agent. How do you configure scope-based access control? In the authorizer config, you need to add an allowed scope with a list of permitted scopes. Here is an example with Amazon Cognito. A client with API write scope is allowed to access our agent. An attempt to invoke the agent by a client with any other scope, for example an API read, will be denied. Scopes are defined in your identity provider. In Cognito, you create them in a resource server, then assign different scopes to different app clients. This lets you have a reader client and a write client, both using the same identity provider but with different levels of access. Let's see this in action with an agent that has an authorizer configured to require API write. What happens when a client invokes the agent with a token that only has API read scope? Agent core validates the JWT, signature, issuer, expiration, everything checks out. But then it checks the scopes. API read is not on the allowed list, so the request is denied with a 403 forbidden. Now the client corrects itself and uses a token with API write scope. Same validation process, but this time the scope matches. Agent core forwards the request to the agent container. The agent processes it and the client gets a 200 OK. Same identity provider, same validation flow, but different result based on what permissions the token carries. Scopes were great for machine-to-machine scenarios where you are controlling what different kind applications can do. But what if you have users authenticating and you want to restrict access based on who they are, their department, their role, their tenant? That's where custom claims come in. Let's take a look. Now let's look at custom claims. Unlike scopes which define what a client can do, custom claims define who the user is, their department, role, tenant, or any other attribute. In the authorizer config, you specify custom claims with validation rules. You provide the claim name, its type, and the match operator. When a request comes in, agent core checks if the token's claim is as expected. If it doesn't match, access is denied. Let's see this in action with an agent that has an authorizer requiring custom department to be equal to security. When an engineering user invokes the agent, their token has a value of engineering in the department custom claim. Agent core validates the JWT, signature and expiration check out, but then it checks the custom claim. Engineering does not equal security, so the request is denied with a 403. Now, an individual from a security team invokes the agent. Their token has custom department value of security. Same validation, but this time the claim matches. Agent core forwards the request to the agent and the user gets a 200 OK. Same IDP, same authentication flow, but different access based on who the user is, not just what the client they are using. That's a complete picture of how Agent Core Identity secures your agent using OAuth 2.0. You configure who's allowed to call your agent, and at runtime, every request is validated before execution. Thanks for watching. If you have questions or want to learn more, check out the Agent Core documentation. Happy building.